Okay, I'm bummed Michigan State just lost. Today we're going to talk about polynomials. This is Sunday the 30th of March, okay? Let's talk about some definitions here. See if I can zoom in a little bit. All right, let's talk about a monomial. Mono is in one. It's going to be in the form of a times x to the k power, okay? A can be anything but 0. K, our exponent, can be 0. And remember, anything to the 0 power is 1. Okay, it's just the number 1, all right? So if you have x to the 0 power, there is no x. It's just a times 1, which would just be a, and that would get you a constant, okay? All right, but so a can't be 0, or else the whole thing goes away. K can be 0 or greater. K must be 0 or greater than or equal to 0, and it has to be an integer for us to be a polynomial, okay? Integers, 1, 2, 3, 4, right? So A is our coefficient. K, the exponent, represents the degree of the monomial. If it's to the third power, it's a 3 degree. X to the fourth, that's an X, 4 degree, okay? That's an abbreviation. 4 degree, okay? Here's some monomials, all right, and their degree. Here's the 6x squared. The coefficient is 6. The degree of this monomial is 2. Here's a monomial, 3. The coefficient is 3. The degree is 0. 3 times x to the 0 power is 3 times 1. Anything to the 0 power is 1. X to the fourth has a coefficient of 1. It's just kind of inferred that there's a 1 there. And the degree of the monomial is 4. Here we have negative root 2 times x to the third. The coefficient is the negative square root of 2. The degree is 3. Okay? All right. Examples of non-monomials. 3x to the 1/2. Okay, that k, the exponent, is not an integer. Okay? 4x times x to the negative 3. The k, the exponent, is negative. Okay? All right, monomials. First, let's talk about a polynomial now. A polynomial, here's my cue to remember the definition. A polynomial is one or more monomial. Okay? You got one or more monomials, you got a polynomial. Okay? Monomials that make up a polynomial are called terms. Okay? And you're used to seeing that word term. Here's a monomial. 3x to the fourth power plus 2x cubed minus x plus 6. Okay, notice x squared's missing. Okay, that's because the coefficient would be what? 0. Okay, but you still have to, sometimes I'll show you when we add or subtract or multiply or divide, you need to put the term there and put a 0 there. Okay, just to keep up as a placeholder for where the x squared would be. Standard form of a polynomial is where your first term, we call it the leading term, has the highest degree. And then you go down in decreasing order. Third degree, there is no second degree, first degree, and 0 degree. This is in standard form. Here's our leading term, and this is what's called the leading coefficient. It's the coefficient of the leading term, okay? That's a 4th degree polynomial, okay? It's the highest degree of the polynomial dictates the degree of the polynomial. So that's a 4th degree polynomial. It's in standard form. That's the leading term. That's the leading coefficient. Okay? And I said again, x squared is missing. Let's see if I cover everything. Standard form, leading term, leading coefficient, degree. All right, we're good. Let's talk about, we're going to add. Okay? All right? You need to recognize, kind of like place values with numbers. I'm adding this polynomial, which is a trinomial, with this binomial. Okay? All right? And I'm always going to be adding. I'll show you subtraction in a second, but I'm going to go. I like stacking things up and putting them in there, and putting the x's here, the x squareds here, the x cubes here. You might not have any x squareds. Put 0x squared. In this case, I'm adding 3x minus 3. So I'm going to write this x squared plus 4x plus 5, and I'm adding. I don't have. This is a plus. So I don't have to change any of the signs. I'm just going to be combining. Okay. I always make it where I'm just combining, and I'll show you next with subtraction here what I mean by that. So I'm just combining these like addition. Okay, I've got a 5 and a negative 3. What's the difference? I've got a 5 and a negative 3. That's going to be plus 2. I've got a plus 4, and this is a plus 3x. That's going to be plus 7x. And then I've got a positive x squared, and I've just added up my terms. But I make sure you need to put everything in the right place value. X to the 0 power, x to the first power, x to the second power. All right? Notice this. I've got x cubed minus 2x squared plus 5x plus 10, standard form, third degree polynomial, leading term, leading coefficients 1. All right? Minus this right here. Okay? 2x squared minus 4x plus 3. This is what I don't like doing. Okay? I don't like setting up minus this because now you've got to, when you subtract, it's all lines up. Here's my term, x to the 0 power, the constants, x to the first, second. But when you start, if you actually subtract, you've got to kind of on the fly distribute. 10 minus a 3. Here's 5 minus a negative, and you could trip yourself up. I do this. I distribute that negative and just add. So I'm going to change this. This negative is distributed to everything in the parentheses here, here, and here. A negative is a sign changer. This would be negative 2x squared plus 4x. Negative and a negative is the positive. And then I got this negative changes this sign to a negative 3. I'll put this right here. And notice now I just have to add. I'm just going to combine everything. Notice I'm in the right columns. 10 and a negative 3 is a plus 7. Plus 5 plus 4 gives me plus 9x. This is the x column, x to the first column. Here's x to the second column, x squared column. I've got a negative 2x and a negative 2x. I'm basically adding all the time this way. That's minus 4x squared. And now I've got this comes down x cubed. And there's your answer. But you need to keep each term in the proper place value. Okay? If you don't have it, you put it, if I didn't have any x's here, I'd put a 0x to keep the placeholder because you don't want this in the wrong place, okay? All right, now let's do multiplication. All right, here I just on purpose left out the middle term, okay? I'm going to set this up just like normal multiplication. X squared plus 4x plus 5. I'm not missing any terms. Constant to the first power, second power, and I'm multiplying by, but here I am missing, I've got an x squared and I've got a 3. I don't have that the term with x to the first power. So what I'm going to do is, here goes negative 3 here, with x, this is x to the 0 power, basically the constant, and I'll put in here a 0x. It's very important that I honor this place, okay? And then I have a plus 3x, a positive 3x, okay? Now, I'm going to do multiplication just like normal. We're multiplying the coefficients, okay, first. Negative 3 times 5 is negative 15. Negative 3 times 4x is minus 12x. And a negative 3 times x squared is minus 3x squared. Now I move over, I use this, instead of putting 0, I move over a place value just like normal, because now I'm starting off in the x to the first place value. It's a 0 times 5 gets me whatever, plus 0x, okay? 0 times 4 and x times x gets me a plus 0x squared, and 0x times x is x cubed, and 0 times 1 is 0x cubed, okay? All right, so notice here I've got this 0 gave me 1, 2, 3, 0 to the x first, x 0x squared, and 0x cubed. Now I move over to this. I've got these two place values already covered, and I move over one more, just like normal multiplication from elementary and 5th, 6th grade. Okay, so now I've got 3x squared times 5. That's 15x squared, positive. Notice how I'm in the correct x squared column. Okay, that's a good catch. Make sure you got x squared. Okay, now I do 3x squared times plus 4x is 12x cubed. Plus 12x cubed. Okay, plus, and finally, 3 times this would be 1, would be, get me an x to the 4th power. 2 plus 2 would be 3x to the 4th. And now I just combine everything. I've got a minus 15. I go to the x, and I've got a negative 12 and 0 and nothing, so that's going to be minus 12x. Here's my x squared column. I've got negative 3 and plus 15, okay? Let me see. Yeah, so that's negative 3 and plus 15, that's, sorry, I got distracted. Plus 12x squared. And over here I've got 0 and 12, and that's plus 12x cubed, plus 12x cubed. And then I don't have anything, just this one column here of 3x to the 4th. Okay? And there you have it. We just multiply just like normal, like you'd be doing, 145 times 3, 0, 3, 0, negative 3, whatever, but just by normal multiplication. But now we've got, thousands, whatever. Instead of ones, tens, hundreds, place value, we've got x to the 0, x squared, x third. Those are the place values, okay? All right, that's 10 minutes. That's coming up on 11 minutes. Signing off. We'll see you tomorrow. Be ready to do one of these problems, okay? Good night.